TLSA for all. In this series, we will discuss digital interview questions which will be helpful in your interview as well. Let's get into the series. First question. What is race around condition in JK flip-flop and how can we avoid it? As we all aware of that JK flip-flop has a race around condition and it is one of the drawback in the JK flip-flop. First of all, what is race around condition? When the in the JK flip-flop, when the clock pulse is high for a long amount of time and when both the JK and J and K inputs are 1, then the output continuously changes or toggles its output state from 1 to 0 and 0 to 1. Continuously toggling, this is called toggling output or uncontrolled changing or racing condition. As we see here in the given figure, see when the clock pulse is high for a long amount of time and when both J, K inputs are high, until that period the output is stable, and when both the JK and inputs are high, then the output is toggling. It's okay. Toggling is up to some extent. But when the clock pulse is high for a long amount of time, then it cannot resist like that. It is keeps on toggling until the clock pulse is high. When the clock pulse is low, then the toggling is off. This is also termed as invalid condition in JK flip-flop, which is one of the drawback, and we have to avoid it. Why? Because the JK flip-flop has this drawback. We have to avoid this drawback. What we can do to avoid? So what we have to do is the clock on time should be decreased. The clock on time should be decreased so that uh, we can have overcome the race around condition. And also, if the flip flop is made to toggle over one clock period, then racing can be avoided. And this is introducing the concept of master slave JK flip flop. Means what? JK flip flop can be overcome by using master slave JK flip flop. Is it right? It is one of the master slave is overcoming the race around condition which we facing in JK flip flop. Next question. What is master slave configuration? Before question only, we know that JK flip-flop has a resurround condition and it is overcome by using a master slave configuration. Now, see here, what is master slave configuration? The master slave configuration, how it is constructed? It is constructed by using two JK flip-flops. One is by using a master and one is called a slave. And for one flip-flop, clock is provided, and to another flip-flop, the complement of that clock is provided. See, one is called the master and another clock is called the slave, and the JK inputs are as usual and Q bar outputs are given. Then how it will reduce the condition? Let's see. When clock pulse is high and JK inputs are high, what happens? The output keeps on toggling, right here. The output keeps on toggling here, but when this this clock is high, this clock is low. So it cannot do anything. The J and K inputs are no. We will get only one output and it can't do anything. So what will be the output of the slave? The output of the slave will be no change. Means what output comes here first, that output only comes here out of it. So the toggling condition can be avoided by using this master slave configuration. Okay, next question. How can we implement 4 is to 2 priority encoder? First of all, an encoder is used to encode the human understandable form into binary form. That is the use of an encoder. Then why here we are using priority encoders? Encoder is used to encode, whereas priority encoder want to set some priority values to the encoded binary form. It prioritizes the bits in the input stream. When we want to prioritize an input bit, then it will ignore all the other inputs. See here, 4 is to priority encoder. Here D0, D1, D2, D3 are the inputs. Here lowest priority input is D0 and highest priority input is D3, and Y0 and Y1 are outputs. See, in this condition, when all the inputs are 0, then the output can be XX, nothing. We are not prioritizing anything. And when the input is 1, then D0, no? D0 means it is encoded in the form of 0, 0. And when it is X and it is 1, what happens? Whether it is D0 is 1 or 0, we never consider the D0. We just come to see that D1 is 1. So we see 0 and 1 because highest priority is D1. And next D2 is high irrespective of other inputs. The D2 is the highest priority. So we will convert it into the form of 1 0, that is 2. And here also the same, because it is setting the priority values in input bit stream, ignore all other lower priority inputs. This is the function of the priority encoder. Next question. What are the applications of buffers? Basically, buffers are what the buffers do. They just pass the data. What data we are giving in the input, the data is given to the output, right? So buffers are used to pass the data, transmit the data, translate the voltages pulses between connected systems. And buffers are also used in registers. Why? Because they are used to store the data, and also used to also used in buses for transferring the data. They are used to transfer the data, store the data, and they are also used to introduce some small delays. And they are also used to eliminate crosstalk caused due to inter-electrode capacitance due to close routing. And they are also used to high fan out. What is high fan out? When we are having a lot of outputs outside, then it is used to support that higher fan out, and it is suitable for higher fan out systems. Thank you.